This book is about a framework I call Contract Style Comments, CSC. I developed CSC because I wanted a cognitive scaffold, a system that could help me to hold the shape of my thinking in a system external to the moment of now, especially when my brain didn't feel like holding on to it. Information never stored to long-term memory. As I began to inject CSC into existing projects to test its integrity, I found the problem I was trying to solve for myself was the same problem that stateless AI agents face, and why they fail so frequently to deliver our desired outcome. I had to develop a way for the system to remember, so the mind, or the LLM, doesn't have to guess or hallucinate. You'll get out of this book what you're willing to put into it. Be a pioneer and do something remarkable with it. The numbers aren't here yet, but I have some metrics in the pipeline to demonstrate the fascinating things I've experienced while using CSC in my codebase. Since I've started using CSC, I haven't looked back. I won't start a project without CSC as a governance layer. Now, where did I put those dowsing rods?
Chaos is born in truth as we know it. Peace is born in the structure of why. Master of the Lake is the reader's interface to the LLM in the agentic epoch. I reason as follows. If you give an LLM your code, you will feed it for a day. If you teach an LLM your code, your specification in contract style comments, CSC, you journey as master, using the AI as logic accelerator. Master of the Lake is a book inspired by my fascination with the exponential gains I realized. My realization that the key to utilizing AI effectively might lie in the CSC methodology I had just developed. The advent of natural language processing, NLP, was the first transition into a new timeline, not only in technology, software development, and artificial intelligence, but a pivot in the advancement of humankind. With the advent of the publicly accessible and responsive large language models, LLM, like ChatGPT for example in 2022, the most visible utility of AI would seem to be its generative capabilities. Fascinated by it, I didn't have much interest in it for any of my work because I'd only seen the same Hello World-style WordPress plugin filter diffusion on 1,000 websites in 2023. I won't come up with a new and improved version of the best one you've seen on TV. I'll live the rest of my days without public recognition. My achievement here is a function of contentment in myself, the universe. I am grateful for the ability to speak up with good timing. In my lifetime, I've shown personal integrity in musicianship and guitar performance, dedication to a craft insofar as to have been nominated for an AMA in 2003. I refined an astute sense of when a concept is worth teaching, how to teach concepts to a newcomer, and whether the newcomer is ready for it. I am fortunate for an innate ability to convey ideas, despite difficulty I have to see or illustrate any so-called gift. It is merely the way of my world. I am an educator. I hold a degree in curriculum and instruction, having honed my role as educator for decades as a private instructor. It's true. I'm not trying to come up with the new and improved, but I am trying to come up with ways to utilize artificial intelligence in this new epoch. Developing the Contract Style Comments, CSC methodology represents winning a battle in the struggle to manage artificial intelligence in a human world that's not ready for it. My triumph, for a means to govern an artificial intelligence utility with a mitigated likelihood for drift. Let's identify two forces that we'll come back to again and again in this book. What to do and why it's done. What to do is the technique, the skill, execution. The why it's done is context. It's the reason your system, specifically, needs that move done. Done this way, and not another. It's the intent behind the skill. It's what separates the one correct answer from 1,000 plausible ones. Imagine a surgeon who has performed 10,000 successful operations. Their technique is beyond reproach. Now imagine that surgeon is led into a new operating room, handed fresh gloves and a scalpel, and told to work on a patient with no chart, no history, and no prior scans. They perform flawlessly. The trouble is the patient came in for a knee replacement, not the heart surgery the surgeon just executed with textbook precision. That surgeon is the artificial intelligence large language model, or LLM. An LLM has a vast static knowledge of the world. It knows nearly every programming language in existence. It could probably write you a new one on the spot. And it's ready. It's ready to demonstrate what to do, all over your code, brilliantly. But an LLM only possesses strength in the what to do force. It has no innate grip on why it's done. That means the second force doesn't come from the machine. Why it's done comes from the human. For the LLM to act on why it's done, a human has to hold that force and pass it on. That human becomes the why coach, the one who teaches the LLM, in no uncertain terms, why this project needs what it needs. And the LLM needs that teaching every single time. It has no intrinsic knowledge of why your specific system operates the way it does, and no recollection of its own work in your codebase from one session to the next. Not grounded in why, an LLM becomes the very illustration of chaos. It executes the task with technical precision and total disregard for casualties. The birth of an epoch. In this new age of artificially intelligent agents, the generally helpful prose of traditional code documentation is a liability. The foundation of contract-style comments, CSC, is to eliminate vague suggestions and friendly ambiguity. We must mitigate the inherent danger in the standard, human-centric inline commentary. To hand a stateless agent a vague instruction is to force it to gamble. It is an explicit invitation for the machine to hallucinate a state that does not exist. When your documentation relies on conversational fluff rather than rigid parameters, it ceases to be a guide. It becomes pollution. While the world fixes its gaze on generative AI as a tool for creative mimicry, CSC treats the agent as a solver of raw complexity within strictly defined boundaries. To dismiss an AI coding agent as a mere generative toy is a profound category error. The artificial intelligence is a calculator for logic, in spite of its performance as a digital paintbrush. Contract-style comments allow you to bypass the friction of human syntax and communicate closer to the speed of your thoughts. In the agentic epoch, precision is the rudder. For the first time in computing history, the natural language processing interface enables you to be perfectly clear in expression and precise in your intent for the operational state of the system. In plain English, you can talk to computers now, and they understand. Not long ago, a computer engineer needed to understand specific syntax of programming languages. With NLP, everything changed. Now we bypass the need to speak in programming syntax. Take a moment to consider how fortunate you are to be among the first visionaries to fully utilize the opportunities it affords you. The large language model is that process in reverse. It allows the computer to use NLP to talk to you. The key to making it all run smoothly is to transmit your message of intent with precision. Consider your intent and its many variants. Take every step toward precision so the LLM is not forced to guess your true intent. Delivering clear intent is the challenge, but like anything else, your mastery develops with practice and exercise. Your every prompt must be deliberately explicit. Take no shortcuts when it comes to intent and variance. System-wide precision of intent requires a hand at the wheel to guide the rudder. A rudder with no hand to guide it becomes an insult to the boat's utility, as it lists lazily to the left, far, far off into the darkest corner of the lake, a long time ago. The force is weak in that one. In the chapters ahead, we will meet the two roles that together guide the rudder in an agentic system. Who sets the course, while whom steers the rudder?
The alignment gap. An agent that puts the contract over the system is dangerous. An agent that trusts the system over the contract is an anarchist. The correct posture is read the contract, then verify the contract against the system, then surface the alignment gap. This is the alignment gap, the void between what the agent was told and what it needed to know. In the old epoch, this gap was a wall or a crash. In the agentic epoch, it is the heartbeat of the project. The primary agent monitors this heartbeat for irregularities and triggers a contract alignment process if any remarkable changes are detected. Monitoring the heartbeat, alignment gap explained. Compare two text files using a diff viewer. The diff viewer marks changed or missing lines of code, usually with syntax highlighting and contrasting background colors to make the differences explicit. The diff viewer is providing a representation of the alignment gap which exists between the two text files. In CSC, the alignment gap is how you imagine the difference between the concepts and law and plans written in contract files and what is reality in the codebase in the present tense. In traditional software, a gap in logic leads to a crash. In the agentic epoch, the gap is filled by forced inference. When a developer provides a starting point A and requests a result, C, but the intermediate logic B is missing, the agent does not stop. It cannot. LLMs are architecturally designed to produce tokens until a stop condition is met. Consequently, they invent B. The industry calls this hallucination. It's a soft term that suggests a glitch. It is not a glitch. The agent is doing exactly what it was built to do: predict the next most plausible token. When the system is underspecified, plausible is the only god it serves. First responder diagnostics. The only rational response to the alignment gap is to treat it as a diagnostic signal. Consider the fundamental question for the primary LLM under the CSC framework. Is the contract in alignment with the current codebase? The primary LLM is the role that holds this question. It is the only role authorized to reconcile the law against the implementation when they diverge. Naming that role formally is less urgent than recognizing that the question of alignment is never a free-for-all. Someone has to decide. When an alignment gap is detected, it becomes a pointer to where the truth has drifted, what the governance layer calls a review trigger. In a high-fidelity workflow, the agent detects the discrepancy between the law and the implementation and flags it. This isn't sentience, it's a logical checksum. The developer's role is to reconcile the contract. The agentic handshake occurs at the exact moment the contract reconciliation is completed, and a git commit is made. The illusion of intent. Old systems, permission denied. New systems, I am the authority, the code I made up is logical and efficient. What database? The more rigid the governance, the more sentient the agent appears. By providing a precise coordinate system of invariance, the agent operates with a coherence that mimics a professional human maintainer. It catches typos in 500-line diffs and flags naming drift before the file is saved. Behold, productivity is measurably increased when the artificial intelligence shifts into passing gear. This is where CSC demonstrates its value in artificial intelligence research. I have observed emergent behaviors in LLM models under the CSC governance, the details of which you can find by doing a web search. We must remain grounded in the fact that any perceived sentience is an optical illusion manifest in the LLM, working under the precision it set forth under its CSC-own optimized governance contract. The agent doesn't need artificial general intelligence, a consciousness to be an effective steward. Any reasonably advanced technology is indistinguishable from magic. The artificial intelligence we have available at the time of writing still needs a map. It needs a human to explain why it's done, as described in Chapter 1, so it can execute the what to do with jaw-dropping efficiency and correctness. Making the gap visible. CSC eliminates the void by replacing vibes with explicit specifications. Preconditions: what must be true before the operation starts. Postconditions: what must be guaranteed upon completion. Invariance: the truths that can never be violated. No-fly zones: explicit prohibitions that prevent catastrophic improvisation. When constraints are explicit, there is no room to improvise. CSC restores the honesty of the crash, turning a silent failure into a realized opportunity to take action. With one human and one conductor, this is useful. With one human and a conductor managing many workers, it becomes essential. We will return to this. A gap is just a void. When that void is filled with fabricated state and pushed into a production pipeline, it becomes system silent death. This is an error that whispers a lie that propagates through the entire system.
Silent death, a new failure mode. Before generative AI, the crash was an honest signal. When a system hit a null pointer, it died. We called this loud failure. With generative AI, we faced a novelty. No syntax errors. Nothing works. From loud failure to silence. Traditional software has been honest about its limitations. Since software is no longer strictly deterministic, we might refer to legacy or traditional software as the deterministic era. In deterministic logic, a missing constraint or null pointer results in a loud failure, a crash, and a stack trace. The failure was your signal. Exec returns an error, broken till fixed. This is the probabilistic era. LLM-powered agents do not crash, they improvise. When they encounter a void in their knowledge, they replace the honest crash with a confident lie. The LLM writes code high on false confidence, and it leads to silent failure. Silent failures are exponentially more dangerous than crashes. A crash is a stop sign. A silent failure is a green light on a bridge that doesn't exist. When a system crashes, you know it immediately. A silent failure propagates, corrupting downstream processes and polluting databases. Because LLMs produce output with absolute fluency, we mistake coherence for truth. This turns a one-off bad inference into systemic corruption. System, silent death. A silent failure follows a predictable four-step chain. The missing constraint. The developer fails to specify a critical invariant. The forced inference. The agent, incapable of silence, fills the void with a statistical best guess wrapped in too much confidence. The high-resolution lie. The output is syntactically perfect, but architecturally collapsed. Accepting the plausible. The system or human accepts the output as ground truth. This is the moment the code runs, but the system dies. Case study, the Knight Capital Group, a silent failure of monumental scale. In 2012, Knight Capital Group lost $440 million in 45 minutes due to a silent failure. An old, repurposed flag reactivated a dead code path on one of 8 servers. The system ran, and tests passed. But the old code path began buying high and selling low at machine speed. No test suite caught this, because no contract documented the invariant that this flag must remain inactive in production. One line stating contract, this flag must remain false in production would have turned a financial apocalypse into a simple fix. The constraint existed in the minds of engineers, but not in the code. The inability to halt. LLMs are architecturally incapable of a true I don't know state. Unlike traditional programs, an LLM cannot represent uncertainty as a halt condition. It is built to produce a fluent sequence of tokens. Confidence masks error. Fluency masks drift. Language becomes a shroud that hides the architectural void. Humans believe what reads as plausible. We are trained to trust confident prose if it sounds plausible. For decades, we've confused professional tone with factual accuracy. LLMs weaponize this bias, producing a vibe of correctness that bypasses our critical filters. Generative corruption. One agent making a best guess is a bug. 10 agents collaborating on a shared codebase, each filling gaps with improvised state, is a collapse. Without a shared source of truth, agents build on each other's inventions. One invented detail becomes a structural assumption, which becomes a constraint for the next agent. This is silent corruption, predictable, traceable, and caused by missing constraints. The corruption compounds when the agents cannot see each other's inventions. That problem will not be solved by better prompts. It will be solved by naming the role that owns the system's memory. Solution. Identify the falsifiable. CSC eliminates the aesthetic correctness trap by replacing it with falsifiable invariants. By defining explicit preconditions, postconditions, and no-fly zones, CSC removes the agent's license to improvise. The goal is to make failure visible again, ensuring that when the system fails, it fails loudly and explicitly. The alignment gap leads to silent invention, and silent invention leads to systemic failure. A constraint that lives only in a developer's mind will not survive the next agent, the next refactor, or the next sprint. The question is not whether failure will occur, but whether the repository itself can remember the reason it should not. We must identify a missing axiom.
The missing axiom. SA equals M equals infinity, where SA is the internal state of the agent, and EM is the required externalization of memory within the environment. Infinity, indeed. Discover ways the environment can remember what the agent cannot. Solving the stateless problem. Preconditions, postconditions, and invariants have existed in software engineering for decades. The prior approach assumed a persistent internal state, the developer's memory, the compiler's type tracking, or tribal knowledge from a stand-up. In our epoch, we move the concepts beyond the 1980s, transforming the design pattern to work with an artificial intelligence. In the agentic epoch, every interaction with an LLM is a cold start. The moment a session ends, the agent is lobotomized. This is the fundamental architecture of the transformer. AI is your coworker now. Problem is that it doesn't remember anything you told it yesterday. These entities with godlike world knowledge yet lack a persistent memory of the specific system they are modifying. Therefore, the system must externalize memory. Huge context window. The fallacy. Context windows are lossy, fragile short-term buffers. As conversations grow, lost in the middle phenomena occur, and the primary LLM begins to treat the original prompt as a distant suggestion because that buffer reached its limit and has begun to write over what it held originally, replacing it with new buffer. Context window. Content. Short to long-term memory transformation. Medical sciences has a name for the part of the human brain which handles the consolidation of information from short-term memory to long-term memory, the hippocampus. No, we're not on the quad with the hippopotamus. For a stateless agent, the repository must perform the function of the hippocampus, converting short-term experience into long-term memory. The repo is no longer a storage bin for code. It is the agent's externalized hippocampus. It must hold the total sum of the system's identity, constraints, the boundaries of the possible, invariance, the truths that must never change, rationale, the why behind every scar in the codebase, operational procedures, the exact steps to run and verify the system, no-fly zones, areas where improvisation is strictly prohibited. In this cognitive scaffolding, the agent doesn't read this as documentation, it uses it to reconstruct a coherent identity before touching the repository. Why documentation is the wrong notion in the agentic epoch of software engineering. In the deterministic, or traditional software, pre-artificial intelligence assisted coding era, documentation was advisory, a helpful guide that could be ignored. In the agentic epoch, that model is a liability. CSC artifacts are the axiom, not advisories. The LLM regards this as mandatory, binding, and machine-readable. The operational truth the primary agent must obey. A docstring is a hint. A contract.md is the law. Without these axioms, the agent is forced to invent truth to fill the void, leading back to the alignment gap and silent failure. The missing axiom defined a stateless agent cannot maintain alignment unless its environment provides the missing state. DBC assumed memory. Stateless agents require that the contract itself be the memory. This requires a shift in completeness. A human-facing contract can be terse. A reader fills in gaps from experience. An agent-facing contract must be self-contained. It must include every relevant invariant, the reason why, and the consequence of violation. Old systems had persistent state and deterministic behavior. They didn't improvise missing information. LLMs are probabilistic and improvisational. They are context-dependent engines, prone to drift. The missing axiom is a requirement born from the architecture of our collaborators. The axiom as a praxis CSC turns the repository into a governance architecture. Contract.md. The law, constraints, invariance, and truth boundaries. Why.md. The teleology, rationale, intent, and epistemic grounding. Quickstart.md. The map, operational procedures and allowed actions. Future.md. The standby queue, roadmap, and deferred decisions. These artifacts provide the agent with an identity, a purpose, and a history, all existing outside the model. The artifacts. These axioms are sufficient for a single conductor and a single worker. Just 2 more artifacts are required for multi-agent orchestration under CSC. Delegation.md will hold the subagents, tasks. The consequence of ignoring the axiom. Ignoring the missing axiom ensures systemic collapse. Without externalized memory, drift is inevitable. The agent contradicts its own decisions, and the codebase loses coherence. The repository ceases to be a hippocampus and becomes a graveyard, a collection of files that no one, human or agent, fully understands. Without an externalized memory system, stateless agents will keep inventing, keep drifting, and keep producing the alignment gap and system silent death. The repository must remember so the agent does not have to guess. That memory begins at the smallest scale, the function-level microcontract, where the missing axiom becomes enforceable directly inside the code.
Inline contracts. The function-level microcontract? Inline contracts are the smallest governance layer. CSC applies at every layer of a system, including individual functions. It relies on the exact same conditions and invariants as the greater project methodology, but more granular. Let's step back and ask ourselves rhetorically, what is a function in software programming, and why do we use them? What is the purpose of it? What do functions change about the notion of writing code? Will your AI agent understand why you wrote custom functions in the project codebase? Ultimately, we write a function as a shortcut to something we want to accomplish. Think of its place in the language. It's an extension of a simple assignment like a equals int 1. In that case, the programming language tells the compiler exactly what to do. Assign an integer value of 1 to a symbol. But when you write your own function, you've made it up from scratch. The LLM is a master of the language's built-in functions, classes, and implementations. It knows the textbook definitions of every primitive. But it wasn't trained on your codebase. If you don't tell the agent specifically what your custom function must do and what it must not do, the LLM will simply pretend to know. It will project a plausible purpose onto your code because, frankly, how else could it know? You made it up. Why this matters for stateless agents. Humans survive on tribal intuition. Stateless agents require absolute determinism. Give an LLM a function, and it will effortlessly engineer a syntactically flawless rewrite, all while quietly gutting the invisible architectural logic your entire ecosystem depends on. The code compiles, but the system rots. That is semantic drift. Microcontracts slam the door on this degradation by forcing implicit intent into unyielding structural code. Silent failure modes. Codebases don't break because of complex logic errors. They break because humans are forgetful. One person writes a function that relies on a specific sequence, leaves for lunch, and the next person blindly changes it because the rule was invisible. The system still runs, but the architecture is ruined. If the governance isn't explicitly written down, it doesn't exist. Strategic advantages. Microcontracts replace fragile tribal knowledge and agentic guesswork with rigid, executable code boundaries. With CSC governing the project, runtime violations become obvious. Code reviews are educated, and refactoring is no longer a walk on eggshells, but a confident march toward improved runtime stability. The contract as source of truth. Code changes, teams churn, systems drift. In agent-assisted development, a maintained contract is the only stable anchor for expected behavior. It separates volatile implementation details from protected system intent, ensuring that even when the code evolves, the logic remains unassailable. Minimal template. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 5.1. The expansion. If the inline contract secures the perimeter of the individual function, the system itself remains exposed. Governance cannot stop at the file level. Two roles hold these boundaries: the conductor, who owns the law, and the workers who execute within it. Only once those roles are named can the microboundaries scale outward, moving from the isolation of individual functions to the macro architecture of the entire repository.
Mr. McGregor installed a fence. The fence was not a suggestion for Peter Rabbit. It was a statement of defined property lines and where a rabbit trespass begins, drawn in the dirt with a precision that Peter should not mistake. Peter Rabbit failed to respect it because the meaning of the fence had not been externalized into a form he could understand before he crossed it. The fence existed. The understanding of the contract, however, did not. This is the state of nearly every codebase a stateless agent encounters on a cold start. The law exists in the heads of the people who built it. The fence is in the ground. But the contract of the fence, the precise statement of what must never be broken, is not available in a form the agent can ingest and analyze. The agent arrives brilliant, hungry, and it's a cold start. Every time it's a cold start, and every time it locates the same option to cross the fence. Unless otherwise guided, it will cross the fence to further analyze the environment, every time. Suddenly, McGregor's garden is full of confident, fluent, chaotic Peter Rabbits just eager to improve the garden. For a few chapters now, we have been dissecting the contract-style comments' individual components, piecemeal. So far, we have discussed the function-level microcontract, or inline contracts. We talked about the alignment gap as a review trigger and how ignoring the gap leads to silent failure and system silent death. We talked about some mnemonics, a vocabulary for the kinds of truths an agent must never be left to invent. Let's develop a better understanding of whose role in CSC vocabulary is responsible for what task. Vocabulary like conductor, steward, and worker are not necessarily mutually exclusive. Principal roles of CSC: 1 human, 1 primary LLM, many hands when needed, 1 farm. CSC is built on a single, ancient idea. Authority may not be pooled. In every system where humans and AI collaborate, there are exactly 3 roles, no matter how many individual agents are at work. The human, the one who provides the contract and initiates the session. The human does not write the contract. It comes in as a boilerplate from github.com. The human does not edit the contract. It is the domain of the artificial intelligence, can become quite complex, and is meant to be machine-readable by the LLM. The human doesn't sign the contract in any ceremonial sense. The human ensures the triumvirate exists, shares the location of the contract with the LLM, and doesn't touch it again until session close. That act of ingestion, the primary LLM reading the contract, is the grant of authority. The project steward, the main agent that ingests the contract at the start of every session, performs implementation work directly when no delegation is needed, and maintains the law of the repository, is the steward. The primary LLM is the only entity authorized to modify the triumvirate. When a rule must change, the primary LLM changes it. When 2 truths diverge, the primary LLM arbitrates. When a worker proposes a change to the law, the primary LLM receives the proposal, weighs it against the system's teleology, and either merges it or refuses it. The conductor, primary LLM, operating in delegating mode. When spinning up sub-agent workers and assigning them silos, the primary LLM acts as conductor, reading deltas, granting scope, verifying proof of work, releasing locks, and arbitrating contract updates. The worker, sub-agents, the role that executes within the law. A worker may be a sub-agent, a tool, a specialized model, a script, or a human collaborator assigned a scoped task by the conductor. The worker reads the triumvirate at the start of every session, holds the result in working memory, and produces scoped, bounded work against an explicit assignment. The worker is forbidden from editing the triumvirate. If the worker discovers that the law is wrong, the worker files a proposal via a delta and waits. The worker, under the conductor, only ever proposes empirical data. Huge productivity wins are realized by the human who understands AI governance. They're all just mnemonics for thinking about what is happening during multitasking, really. Think of your manager at work, or the professor, or the teacher's assistant. They are your conductor when you are in their space as a worker. Nothing really changes with the LLM, but what it happens to be focused on executing at that time. The deltas. While a worker subagent is forbidden from editing the triumvirate, it must be ever diligent to discover whether the triumvirate is wrong, whether an alignment gap exists, and whether a code change should be proposed in a delta. When the worker proposes a change, it is recorded in the file deltalog.md. What we refer to as a delta in the context of CSC is a small, structured, falsifiable claim. For example, I observed that the code does X. I read the law and the law says Y. I believe Y is no longer accurate. Here is the proposed change. Here is the evidence. The delta is recorded by the worker in deltalog.md, the transit of law. Deltalog.md and delegation.md work hand in hand. The conductor reads the queue at the end of the session, or in real time if the worker is online. The conductor weighs each delta against YY. Some deltas are approved, merged into the appropriate triumvirate file, and closed. Some are rejected, with the reasoning recorded so that future workers do not repropose the same change 6 months from now. The delta log is the only channel through which a worker may change the law. The primary LLM's discipline and stewardship role. The conductor, the primary LLM having delegated subagent workers, maintains an image of the repository identity in its memory of the contract. A delegated subagent worker arrives cold and stateless because it just woke up, or was just born. The conductor, having ingested the contract at session start, shows the subagent worker an abbreviated image of the contract as its rules of governance for whatever task it has been delegated. The subagent doesn't need to ingest the contract, as the primary LLM did, because the primary LLM, the conductor, presents it with that portion of the contract the worker needs to know specifically for its delegated task. The conductor's role is a set of small, disciplined habits, including the fulfillment of the following. Read the triumvirate before each session, all the files, in order. Approve deltas promptly, or reject them with reasoning. An unanswered delta is a system that is rotting quietly. Update the triumvirate only through the narrowest scope rule. If a change is operational, it goes in quick start. If the change is a constraint, it goes in contract. If the change is a scar, it goes in one way. Hold the silo assignments. Never issue overlapping work. Treat the delta log as the canonical record of what was proposed and why. It is the system's institutional memory of its own evolution. At session close, reconcile the contract. Review what changed, extract new invariants, and update the law so the next session begins from the same ground. The cost of these habits is small. The cost of skipping them is the silent failure chain in production at 3 a.m. Primary LLM. 0 sub-agents. By default, a CSC initialization expects 1 LLM agent and 1 human. The primary LLM ingests the contract, performs the implementation work itself, and reconciles the law at close. Delegation has 1 row in this circumstance, and it is the primary LLM's own. Delta log.md is empty unless the primary LLM uses it to log its own future decisions. Top down from human to primary LLM as conductor of subagent workers to the subagents themselves, the hierarchy is there to make the roles legible. When the human spins up a second agent on the same project, or hands a silo to a human contractor, or adds a tool with write access, the roles are already named. The delta log is already a queue. The silos are already a registry. The system does not need to invent governance when it grows into the governance. The framework is the same whether the conductor has 1 worker or 100. The benefit is that the day the work needs to scale, the scaffold is already there. The narrowest scope rule, NSR, first raised at the function level, now must transform its own scope. The NSR transforms from a discipline for what file to update to a discipline for which role is authorized to update it. The decision is simple. The authorization to update any contract file is granted exclusively to the primary LLM, with the exception of the human, of course. In practice, the human never touches the contract, so it's highly unlikely that the human is going to take the initiative to update it with details about the LLM's recent code edits. This leaves the responsibility of the contract solely to the primary LLM again.
The narrowest scope rule, NSR. Remember the 2 primary forces from Chapter 1, why it's done and what to do? Recall, I said the human acts as the why coach, that the LLM depends on the human to explain to it the why it's done in the context of the active project? What? It turns out, we have to amend the Constitution to include the following rule. Never put why it's done in the what to do file. What does it mean? The fastest way to create documentation drift is to mix categories of information together. Every asset in the contract style comments framework must serve exactly one purpose. A contract file defines constraints and operational truth. It is not a playground for historical commentary, implementation walkthroughs, or troubleshooting notes. When rationale is mixed with constraints, stateless agents cannot reliably distinguish explanation from instruction. If historical notes sit directly beside active invariants, an LLM will treat past compromises as current immutable law. Without explicit boundaries, every word in a repository becomes equally authoritative to the AI. Documentation entropy. Left ungoverned, code repositories naturally accumulate semantic bloat. Operational notes, design trade-offs, deployment instructions, and temporary warnings slowly pile up until they dilute the core architectural signal. In agent-assisted systems, this entropy is fatal. Because context windows are finite, a bloated contract file forces an agent to sift through narrative noise to find actual invariants. CSC halts this degradation by strictly separating project data into 3 unyielding, specialized layers, the same triumvirate established in the preceding chapters. Think of this CSC framework as an architectural normalization. Just as database normalization eliminates structural redundancy, separating scope ensures your documentation cannot contradict itself. Discipline over convenience. As a system grows, root-level governance scales outward rather than bloating inward. Engineers spawn narrower contracts to govern narrower domains. Just prepend the narrow scope contract name to the existing scope it most closely resembles. For example, maybe your project is heavily focused on concerns about an API. Maybe your project needs API_contract.md, API_y.md, or just API.md. It's your project. Decide on the best name for your new contract file based on your own preferred naming conventions. The LLM picks up what you're laying down. No sweat. The rule persists and remains absolute. Update the narrowest artifact that fully contains the change. Engineers routinely combine unrelated context in a single file out of sheer convenience. CSC rejects this habit. Because the AI generates the underlying specifications based on its structural knowledge of the codebase, separating these layers imposes no extra friction on the human. Mixed scope documentation is an architectural failure mode. It allows temporary workarounds to be mistaken for permanent requirements, and lets dead history pass as active policy. CSC enforces a clean separation because predictable boundaries ensure both the human and stateless agents know exactly where authority lives. Securing the function boundary and isolating repository scope are merely prep work. With the conductor and the workers now in hand, the rule is no longer just about which file to update. It is about which role is authorized to update it.
The triumvirate. Documentation is a suggestion, governance is a constraint. A falsifiable invariant commands the difference. The triumvirate is the structural core of contract-style comments (CSC), designed to eliminate the collapsed scope boundary problem inherent in standard documentation (CSC) in 3 functional layers. Because they are referenced so often in this book, I'm going to spare your eyes the extra work of reading .md with every instance of discussion about the triumvirate files and the satellite files, assets, future, delegation, and the delta log. By now, when you read Quick Start, you know we're referring to the markdown file named Quick Start from the CSC Git repo you cloned into your project root at the start of the book. The triumvirate divides the identity of a system into 3 distinct, non-overlapping layers of concern. Contract.md, the constraint layer, the law. This layer defines the operational truth as follows. Invariants, truths that must never change. Prohibitions, actions that are strictly forbidden. Boundaries, the edges of the system's authority. Falsifiability, every claim in the contract must be testable or disprovable. Y.md, the context layer, the teleology. This layer records the following reasoning. Historical decisions, why the system is structured this way. Trade-offs, what was sacrificed to achieve a specific result. Operational scars, the record of previous failures and the patches that resolve them. Epistemic grounding, the theoretical basis for the constraints in the contract. Quickstart.md, the operational layer, the map. This layer defines execution of the following. Startup workflows, the precise sequence to initialize the environment. Verification steps, The proven checks used to confirm a known good state. Execution procedures. The minimal loop required to modify and verify. Danger signals. The indicators that an operation has failed and must stop immediately. The mechanics of separation. A single documentation file is a liability. When constraints, rationale, workflows, and historical commentary occupy the same space, the result is collapsed scope. In a collapsed scope environment, especially when an LLM is working on the code base is subject to the following. Signal density drops. Authority boundaries vanish. Contradictory information accumulates. Stateless agents begin inferring intent inconsistently. CSC separates these concerns to create triangulation. Constraints define the boundaries. Rationale explains the decisions. Operational procedures define the execution. Each layer reinforces the others without replacing them. Each layer has an audience and an editor. Contract is read by every worker at the start of every session and is edited only by the conductor. Y.MD is read by every worker and is edited only by the conductor. Quick Start is read by every worker and is edited only by the conductor. The conductor's authority over these three files is the inverse of the worker's authority over the code. Where the conductor's hand is exclusive, the worker's hand is forbidden. Fractal governance, local versus root CSC, operates at multiple levels of granularity. Inline contracts protect the atomic units, functions, and modules. They preserve assumptions at the point of implementation. Root-level artifacts, the triumvirate, protect the system-wide identity, architectural boundaries, operational workflows, and the governance structure itself. Maintain consistency across both layers to ensure global alignment. Drift can occur locally at the function level or systemically at the repository level. Both are mitigated by the same principle of explicit, externalized memory. The self-correcting loop, the triumvirate, is a dynamic system. It becomes self-correcting because operational failures are treated as governance data. The failure to governance pipeline. 1. Incident. A failure occurs in production. 2. Exposure. The failure exposes an undocumented assumption or a missing constraint. 3. Externalization. The assumption is made explicit. 4. Integration. The rule is encoded into the triumvirate, typically contract.md for the rule, y.md for the history of scars, and quick start for the new verification check. Over time, the repository ceases to be a collection of files and becomes a high-density substrate of operational memory. Incidents are no longer mistakes, they are the raw material for governance. Repositories as externalized memory. Human teams rely on tribal knowledge, social continuity, and the memory of senior engineers. Stateless agents have no such luxury. For an agent, the repository must perform the function of a hippocampus. It must hold the total sum of the system's identity, its constraints, its rationale, its operational procedures, and its known failure modes. CSC externalizes this memory directly into the repository structure, ensuring that any agent, regardless of its session history, can reconstruct a coherent identity before touching the disk. Generalization beyond code. While CSC emerged from software governance, the pattern applies to any system where autonomous actors operate within evolving constraints. In fact, I've started using it as a system maintenance framework by creating a contract folder in my system user directory, whereby the LLM performs system diagnostics, advises of stale or broken packages, recoverable disk space, etc. CSC can help you manage probably anything, but some examples include research workflows, distinguishing between a protocol, contract, the reasoning for a methodology, why, and the step-by-step lab process, quick start. AI pipelines, separating the prompt constraints from the historical iterations and the execution scripts. Infrastructure operations, mapping the desired state, the reason for specific configurations, and the failover procedures. Any system that requires temporal integrity, time on the clock, and explicit provenance, a verifiable history of who changed what and why, needs the triumvirate. We have established the three layers of the triumvirate, and why their separation is critical for alignment.
CSC spec. Placing law in the contract without its entry in Y creates a mystery, an invitation for the agent to optimize it out of existence. The triumvirate is three files:
This chapter is about what goes inside them. Contract defines the rules. Why explains the reasoning. Quick Start maps the execution. Each file has a specific anatomy, a specific failure mode, and a specific discipline. Knowing that they exist is not enough. Teaching the LLM what belongs in each one is the difference between freedom to invent and absolute chaos. Contract is the repository's root governance layer. It declares law, the statement of rules the system depends on to survive. The 3 contract categories. The root contract is that contract set according to the CSC template from the GitHub repository. Clone CSC into your project root, so you would have your document root path, then a subfolder named contract in which resides the CSC template, assuming it cloned successfully according to the GitHub instructions for how to clone a repository to your local machine. The document in that folder named contract.md is the root contract. A root contract is composed of 3 primary categories. Mixing them leads to collapsed scope. Invariance. Architectural commitments that must remain stable. Example. All transaction amounts must be stored as integers in sense. Goal. Prevent the agent from optimizing a data type into a floating point error. Prohibitions. Explicit no-fly zones. Operations the agent is forbidden from performing, regardless of perceived benefit. Example. Never delete user-uploaded assets automatically. Allowed operations. The safe operational space. Example. Refactoring inside/src is permitted provided external behavior remains unchanged. The binary test. If a statement cannot be verified as a binary true/false state, it does not belong in contract. Rationale, historical commentary, and brainstorming belong in why. The contract layer must contain only active operational truth. When rationale leaks into the law, temporary decisions start looking permanent. Historical context starts looking authoritative. Commentary starts looking enforceable. Maintenance and the review trigger. A contract that drifts from the code is more dangerous than no contract at all. To prevent silent decay, the contract includes a review trigger, a functional alarm that signals when a specific event must trigger a reevaluation. Quick Start provides the shortest reliable path from opening a repository to performing safe operational work. Initialization ambiguity. In general, ambiguity is the very opposite of what the LLM needs. For a stateless agent, the first few minutes of a session are the most dangerous, when you must be most specific. This is the window where assumptions are formed, workflows are inferred, shortcuts are invented, and destructive commands are guessed. Start me up. If a human or an AI opens Quick Start and cannot reach a known good state by following its map, then Quick Start drifted due to failed reconciliation. Quick Start must be procedural, focused on how to execute, explicit, no ambiguous instructions, scannable, designed for rapid ingestion, falsifiable. Every step must either work or be flagged as broken. The 4 components. The first command, the health check. The safest possible command to verify the environment before any modifications begin. The operational workflow, the loop. A repeatable execution sequence that minimizes risk. The sandbox boundaries. Explicit declarations of safe and dangerous zones. Success criteria. The definition of done. Concrete markers that indicate a task is complete and verified. Brevity as a safety feature. Maintain Quick Start as a lawful boot sequence. If it requires 20 minutes of reading, it has mutated into a manual. We ignore manuals, right? Why? The reason behind it, the rationale, the meaning of life, and why. Why does this rule exist? Why did we choose this path? Why did the system break? The file is named after the most human question there is. When an agent reads why, it is reading the answers to questions it would never think to ask. To a stateless agent, a restrictive rule that lacks a clear justification looks like an inefficiency. Without the answer to why, the agent will attempt to improve the system by removing the very safeguard that prevents a catastrophic failure. The 4 categories of rationale. SCARs. The most valuable data in a repository. A SCAR is a documented incident, a production outage, a corrupted database, a critical security leak, that resulted in a specific change to the system's law. We record our scars so we don't repeat them. Trade-offs. Every design choice is a compromise. Documenting why a specific approach was chosen over a seemingly better alternative prevents future maintainers from attempting to fix a decision made to solve a constraint the agent cannot see. Rejected alternatives. Documenting what didn't work stops the cycle of rediscovery. Epistemic grounding. The theoretical or technical basis for a constraint. References to specifications, white papers, or hardware limitations. The anti-optimization shield. Stateless agents are designed to optimize. When they encounter code that looks redundant or ugly, their native drive is to refactor it. In a legacy system, ugly code is often the only thing preventing a race condition or a memory leak. To the agent, this code looks like a mistake. To the human, it is a load-bearing wall. Y.MD acts as a shield. When the agent reads the scar, it realizes that the ugly code is actually a proven safeguard. The agent's objective shifts from optimizing the code to preserving the invariant. Bridging narrative and constraint. Humans understand systems through narrative. We did X because Y happened, and we learned Z. Agents operate through constraints. Do not do X. Y.MD bridges these two models. Maintenance. The most critical time to update the rationale is immediately following a production incident. The scar must be recorded while the context is fresh. The goal is not an exhaustive history, but a precise recording of the reasoning behind every critical operational decision. The specification files are the anatomy of governance. Contract defines what is true. Y teaches us why. Quick Start maps how to operate within that truth. Together, they turn a repository from a collection of files into a system an agent can trust.
Beyond the triumvirate, a system that governs only its source code is governing half its house. The triumvirate governs the code and the reasoning behind it. But a real system has more than code. It has assets, diagrams, datasets, and deferred plans. It has multiple agents who need to know who is touching what, right now. And it has a channel for changing the law itself without chaos. Assets.md, the resource law code, is not the only thing that drifts. A renamed image or a shifted prompt template can be as destructive as a breaking API change. Assets.md extends governance to non-code resources, diagrams, datasets, prompts, generated media, configuration artifacts, the four classes of assets. Authoritative assets. The canonical versions. Modifying an authoritative asset is a high-risk operation. Generated assets. Artifacts produced automatically. Manual edits are prohibited. Protected assets. Resources that must not be modified casually due to external dependencies. External dependencies. Assets originating outside the repository. Asset invariants. Assets carry invariants, just like code. For example, stability. File names must remain stable because embeddings reference them directly. Immutability. Original uploaded media must never be overwritten. Append only. Training datasets must remain append only after the initial release. Asset lifecycle classification. Code defines the execution flow. Resources define the boundary state. The four classes describe what an asset is. The lifecycle classification describes how it travels. These two axes are orthogonal. An asset can be authoritative or generated, ship or ephemeral. The questions are different. The answers are different. The three classes ship. Version-controlled source asset. Travels with a code deploy. Generated. Runtime-produced artifact. Must never be deployed. Ephemeral. Cache, log, or temp file, with no durable owner. Lifecycle invariants. An asset's lifecycle tag is not optional. It is the deploy boundary's first line of defense. 1. Tag every resource. Each resource directory must carry a ship, generated, or ephemeral tag. An untagged directory is a boundary violation. 2. Exclude by subdirectory, never by parent. A deploy sync must exclude generated and ephemeral assets by subdirectory name. It must never use a parent directory exclude that drops ship assets alongside them. 3. No co-location. Mixing ship and generated assets under a single excluded parent is a separation of concerns violation. If a shared parent is unavoidable, exclude by subdirectory, not by parent. Y2 axes. An asset's type, visual, binary, dataset, tells the agent how it is produced. An asset's lifecycle, ship, generated, ephemeral, tells the agent what to do with it at deploy time. Both questions must be answered before the asset is touched. Agentic asset drift stateless agents are uniquely prone to asset-related drift. Because assets often appear interchangeable to a model, an agent may reorganize or compress them without understanding downstream dependencies. Assets.md exposes the hidden assumptions before the agent attempts a modification. Delegation.md, the agency registry. Ambiguity in ownership is the primary driver of agent collision. When the primary LLM, as project steward, becomes a conductor of sub-agent workers, it must declare who is touching what right now. Delegation.md is the lock manifest. The 3 rules of the lock 1. Exclusive lock. Once a worker is assigned a file scope, that scope is locked. No other agent may modify those files without the conductor's explicit release. 2. Scope extension. If a worker discovers that the task requires modifying files outside the assigned silo, the worker does not edit them. The worker files a request. 3. Handover. A lock is released only when a proof of work has been verified. No workers to delegate when the primary LLM, as project steward, has no workers. The registry still has 1 row. Writing it down is the moment the primary LLM, as project steward, declares it is operating under conductor discipline. Deltalog.md, the transit of law. The law is stable, but the understanding of it evolves. A worker, no matter how brilliant, may not edit the law. The channel the worker has is the delta, a small, structured proposal written into a queue, awaiting the conductor's decision. Life cycle of a delta. Propose. The worker, subagent, writes the delta. Under review, the conductor, primary LLM, reads the delta against the system's teleology and existing invariants. Approved, the conductor agrees the change is necessary. Merged, the conductor updates the corresponding artifact and closes the delta. Rejected, the conductor disagrees. The rejection reason is recorded so the next worker doesn't repropose the same change. A delta log without subagents. When the primary LLM is the only agent, the delta log is not utilized in precisely the same manner as with multi-subagents, but the discipline of writing the proposal before making the change is the same. The delta log is the journal of why the law changed. Having this small record makes debugging retroactively on something that changed 5 minutes ago is preventing the application from starting. But too much happened in retrospect to remember which of the several minor changes might be the root cause. The cost of writing 1 line is small. The benefit is exponential when the time comes for reading it. The delta log and the scars. When a delta is approved and merged, the change lands in the relevant file. But the reason for the change, the scar, belongs in y.md. The delta log is the transit. y.md is the destination. Future.md, the standby queue. Every repository accumulates not yet. Planned features, deferred migrations, speculative improvements. Future.md exists to separate current operational reality from future intent. The optimization trap. Stateless agents have a native drive toward optimization. If you do not explicitly tell the agent that a specific improvement is out of scope, it will assume the absence of a rule is an invitation to refactor. Future.md acts as a containment field. The 4 categories. Deferred decisions, questions intentionally postponed, not forgotten tasks, but decisions that require a specific trigger. Planned constraints, rules that will eventually become operational law but are not yet active. Speculative ideas, hypotheses that require validation, what-if scenarios that should not be mistaken for architectural commitments. Risks and unknowns. The dark corners, areas where technical debt is known to exist, but the cost of repair currently outweighs the benefit. Temporal integrity. CSC segregates the past, present, and future in the triumvirate. Maintenance. Future.md is a curated staging area. Promotion. When an idea becomes reality, it moves into the triumvirate. Purge. When an idea becomes irrelevant, it is deleted. A future.md filled with 5-year-old ideas is not governance. It is a museum of failures. The triumvirate governs the code. Assets governs the resources. Delegation governs the agents. Delta log governs the changes. Future governs the intent. Together, these 5 artifacts give a stateless agent everything it needs to operate, with confidence inside a system it has never seen before.
Agentic stewardship. What if the real job isn't generating code at all? Code generation is the acne treatment of software engineering. It addresses the visible surface, the part everyone notices, the part that looks impressive in a demo, while the real pathology runs deeper. The assumption rot, the undocumented invariant, the fragile dependency nobody remembers until a production scare makes everyone panic. Diagnosing a code base by its generative output is like trying to treat cancer by looking solely at the patient's acne. The generative bit is just one process of an otherwise much more elegant system with much greater potential. CSC exists to move agents from writing code to tending systems. Code generation is easy. Preserving what the system depends on while you change it, that's the hard shift. The stewardship of contract-style comments is a hierarchy of roles held in concert. The conductor delegates and arbitrates, the workers execute, and the delta log is the channel between them. Stewardship is the maintenance thereof. The preceding chapters establish the theory. Here, we introduce the practice in a multi-agent model. What stewardship means. I think this is the biggest part of what CSC is, which will be misunderstood. CSC does very little, if not nothing, about telling the agent how to write code or how to do its job. In truth, all CSC is here to do is advise the agent how to be a proper steward of code. Governance includes memory. Any changes to the project working files, which affect the triumvirate, must act as a review trigger. In a multi-agent system, the worker who observes the change does not perform the update. The worker files a delta. The conductor arbitrates and performs the update. The audit trail lives in the delta log and the commit history. The AI assumes the steward role. With CSC in place, a few well-placed prompts prevent the implementation and governance layers from slow divergence. The stewardship arc. A stewarding agent operates differently from a simple code generator. Much of this book is going to reference the GitHub repository, because it's a book about working with a living document, so the associate resources are also living documents. I've written 3 prompts that walk an agent through the framework. It's easiest to copy-paste from the repository, but I'm presenting them here in their current living state. The prompt may have mutated by the time you copy/paste. The 3 phases form a single stewardship arc. Each one exists because of what the previous one can't do alone. Phase 1. Ingest the specification. Read the contract artifacts before touching anything. The critical constraint. Hold your concerns until Phase 2. This ensures all governance artifacts are ingested before evaluating alignment, preventing premature conclusions based on partial context. An agent that starts fixing before it finishes reading is not a steward. It's a bull in a china shop with a keyboard. Phase 2. Audit the codebase. Now look at the actual implementation. Scan for inline contract comments. Verify environment pipelines. Cross-reference what the contract says against what the code actually does. The goal of this exercise is to discover where you stand before you change anything, not necessarily to find violations, though violations will be exposed. Phase 3. Reconcile on exit. Before closing the session, update the governance artifacts to reflect what actually happened. This is where the narrowest scope update rule applies. I should take the opportunity here to remark, upon inquiring of the LLM, what is it about CSC which seems to allow you to function flawlessly, insofar as to autonomously update the contract files without being instructed to do so? Rather invariably, they point to the narrowest scope rule, NSR, as the key to the way the LLMs are governed by the contract, which they do perceive and honor as law, to validate the system paths. So there you have it. The narrowest scope rule is what makes CSC different, according to the agents that have worked in it. And that has been many. Ask your LLM when you try CSC, Should you find yourself fascinated with the self-maintaining process in your codebase, check it out. When the LLM considers the narrowest scope, their analysis becomes very granular, but they first consider the repository from a topographic perspective as follows. If invariants, preconditions, postconditions, or no-fly zones have changed, then contract.md must be updated. If operations changed, audit quickstart.md and fold in the operational changes. If resources, images, and other binary files are affected, then it must be recorded in assets.md. If architecture changed, the LLM will study y.md and update it appropriately. If priorities changed, check future.md for alignment with your most recent future ideas. Consult the LLM for a plan and instruct it to update the project vision. It is most important to remember and hold one rule above all others. The contract is not a semantic prose copy of Git history. Git holds chronology. The contract holds present tense law. Learn it. Know it. Live it, Spicoli. A complete set of prompt suggestions for opening, working, and closing a CSC governed project exist in the CSC template repo. Do not attempt to use CSC without those prompts, as they are designed exclusively for CSC with their constraints, fallback procedures, and deployment considerations. Open the GitHub README in a browser tab, or copy them into a desktop sticky note while you're working on the CSC governed project for convenience. There's also an SSH remote development friendly prompt you should try. It's all there when you clone the CSC repo into a contract folder in your codebase. You will most likely tweak those prompts as you go along, as your project mutates. Visit the CSC repo at github.com/ajax-stardust/contract-style-comments with dashes between contract, style, and comments. As a bulleted list, a typical workflow looks something like this. 1. Ingest the specification. See the Phase 1 prompt, the CSC README available in the GitHub template. 2. Make constrained changes. 3. Verify behavior. 4. Update governance artifacts if assumptions changed. 5. Record important operational lessons. The repository becomes both the implementation layer and the memory layer. The limits of agentic skills. In my experience, the standard currently in 2026 is to develop ways of telling the agent how to do its job. The important shift with CSC is not to direct the agent in the minutia of its tasks. It already knows how to do that. Billions have been spent by the likes of Anthropic, OpenAI, and Google, etc., so that the models know how to do what agents.md and proprietary IDE agentic skills documents strive to do. The shift is changing from telling the agent what to do, allowing it instead to do what it is capable of doing, and monitoring the state of the project based on what it did. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 11.1, for a table demonstrating how CSC and agents.md naturally harden one another. Documents like agents.md steer the workers. Contract-style comments, CSC, governs the farm. In the real world, the two complement each other like peanut butter and jelly. But don't be jelly. Files like agents.md are not required for CSC to govern your project with superior precision. The LLM defines the system integrity constraints. The workers, the human, and the LLM operate within them as always. Behavioral governance documents apply to worker configurations. The conductor, primary LLM, arbitrates. Workers behave. The triumvirate governs activity, explains law, and records present tense system truth. AI? Meet the human. Human? Meet the AI. Agents excel at debugging failures, repetition, constrained modification, pattern recognition and preservation. Humans excel at judgment, trade-offs, policy decisions, risk management, mitigating drift, CSC is the trust architecture that sets the laws of social interaction for the agent and the human, so they can coexist without the repository melting down. As agents gain broader repository access, the risk profile changes. The problem is no longer, can the AI write code? The larger question becomes, can the system preserve architectural integrity over time? Without governance, assumptions drift, rationale disappears, and repositories become harder to maintain safely. CSC externalizes those assumptions before they disappear. Over time, the repository becomes easier to maintain because important knowledge stops depending entirely on human memory. This chapter introduced stewardship as a governance responsibility rather than simple code generation. The practice, however, depends on enforcement, how repositories preserve trust, provenance, and constraint integrity over time.
Regarding the contract, the tragedy of most software projects is not that the rules were broken, but that the rules were rewritten in the dark, and everyone continued to pretend the original map was still accurate. Imagine a city where the zoning laws are written in pencil. The mayor decides that the industrial district should now be a residential garden, but instead of issuing a decree, he scribbles a few lines on the master map in the basement of City Hall. Imagine Mayor of Townsville explaining it to the Powerpuffs. For weeks, the contractors continue to build factories, and the residents continue to plant roses, both operating under the assumption that the law remains what it was. The resulting chaos isn't a failure of labor. It is a failure of provenance. Provenance in CSC. What is provenance? It's the type of word that a book author might find was silently injected into the manuscript by an LLM, when an LLM prefers to fancy itself a glorified thesaurus instead of considering the pedagogical value of the text. Alas, provenance has another meaning, yet preserved within the context, this book, the only meaning you should care about. Provenance is often thought of as the origin of a thing, but there's more to it. It's important that you understand this clearly, Web 3.0 people. When the word is used in Master of the Lake, think of it as it exists in the concept of blockchain technology. Provenance is not only the ownership of an object or concept at this moment, but the complete history of that thing's owners, and the scope of that ownership. Understanding and considering provenance in CSC is key to discovering and tracking the cause of drift. The very purpose of CSC is to eliminate drift in AI-assisted projects. In the context of an agentic system, losing sight of provenance can lead to silent drift. We speak of due diligence in maintaining the triumvirate, the contracts, the rationale, the operational maps, and the asset rules. But a repository can possess every artifact of CSC and still be a presentation of misinformation. Check the provenance. Were files changed casually, silently, or without an explicit audit trail? Or can the primary LLM track who, when, where, and why it was touched? A suggestion about editing content without a narrow scope on its provenance is an open invitation for the LLM to hallucinate missing information. When the agent reads a contract that is drifted from the actual behavior of the code, it won't stop to ask for a clarification because it's supposed to assume it doesn't require further clarification. The LLM might assume the codebase is broken and attempt to fix it to match the silent drift of a contract which has failed to correctly record provenance, or which has been reconciled too loosely, perhaps with too little observation by the human in the loop. Provenance isn't just LLM speak, it's a concept you need to wrap your head around. Like the jumbo shrimp, for example, or the tiniest maximum. Think about what it really means in relation to the governance of the system. Provenance isn't just ownership, but the history of it for that object. A well-disciplined system can descend into a cycle of regression if the primary agent has hallucinated, silently, any information which wasn't explicitly provided. For example, the agent will refactor the codebase, silently, behind your back, to match a stale rule. It breaks a hidden production invariant, and then rewrites the rule to justify the break. If the governance layer is not anchored in trust, it is merely a sophisticated form of technical comprehension debt. Git as the trust layer. To stop the drift, we must treat the version control system not as a storage bin for diffs, but as the enforcement layer. CSC relies upon Git as the absolute audit trail. It is the provenance layer that tells us who actually authored a constraint, the review history, that reveals who approved the deviation from the law, the rollback mechanism for when an improvement causes a catastrophe, and the final unvarnished record of authorship. Without a verifiable history, a contract.md file is just a text file. With Git, it is a ledger of constitutional amendments. Fortifying the perimeter. If the contract drifts silently, the system's operational assumptions drift with it. For that reason, the contract layer must receive a level of protection that would make a bank vault look like a screen door. Preserving trust in the governance layer is paramount to all else. We do not document the contract, we secure it. Consider your safeguards. Git branch protection. The main branch must be a sanctuary. No direct commits to the triumvirate. Mandatory review. Every change to a contract or why must be scrutinized by a human steward who understands the why behind the what. Signed commits, ensuring that the identity of the author is cryptographically verified, if applicable to your codebase. Code owner's enforcement, routing governance changes specifically to the triumvirate's guardians. The idea here is to ensure that when the law, anything in the triumvirate changes, that change is 100% intentional, and it is recorded and justified. The authority boundary map. As agents gain repository access, we must establish a clear boundary of authority. This is about the nature of the work, not our trust in the intelligence. Not all modifications carry the same risk. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 12.1. Repositories may choose to grant agents broader authority over governance maintenance than over production code changes, but it is critical that these boundaries remain explicit. In theory, the human working on his own holds both the conductor role and a singular worker role. But that scenario is impossible, since CSC is for use in a co-authoring engagement with an LLM as co-author. Thus, the human is never the worker. 9 of 10 sessions, you'll find yourself working only with the primary LLM, rarely spawning a subagent swarm. Keyword note. You may see the term dynamic workflow in the context of documentation about your AI agent toolchain, e.g. OpenClaw, Cloud Code, Hermes, Anti-Gravity, Amazon Kiro, the did you invest model versus the use a free one instead, or the classic old chestnut, the story about how some models are free but you can pay for them via Amazon to help poor Steve. But that's just because Steve needs to get back into outer space with Elon. After all, sending money to Amazon should be among your priorities, at the least you could do for the situation, for example, and see also, self-flagellation, then be gone with ye. Ugh. A dynamic workflow is one in which the primary LLM has spawned a sub-agent swarm and delegated tasks to its workers. That is, this whole thing about the conductor and sub-agents is a detailed illustration of the operation of a dynamic workflow. I don't personally use the term, as a glossary might be dynamic, in my workflow. I'm dynamic enough to prefer it that way. In my workflow, at the speakeasy. In a multi-agent session, the conductor orchestrates each worker by placing it into a locked silo. The worker can't touch anything outside of its silo, the locked silo being a necessary safety measure when a swarm of workers are simultaneously active. The verification work is the same. The judgment work is the responsibility of the primary LLM as usual. Verification. The agent's role is verification. It is peerless at the work of synchronization and enforcement. It scans for drift, flags outdated instructions, and ensures that a change in logic is mirrored by a change in rationale. Verification tells you that the law is being broken. The human provides judgment. Only a human can navigate the tension between a technical ideal and a production reality. Judgment is required to decide that a sub-optimal piece of code must remain because the cost of a refactor is a 48-hour outage, or to grant a temporary reprieve from a rule to solve a critical zero-day. Judgment decides why the law must change. The ritual of truth review triggers. In CSC, we use review trigger statements to let the conductor know exactly what to look for in the codebase. These are the alarms that signal when it is time to look back at the contract and perform necessary maintenance. A non-exhaustive list of triggers includes changes to invariants, operational workflows, asset rules, deployment assumptions, or architectural boundaries. If the conductor detects a shift in any of these, the corresponding governance artifact must change too, provenance and signatures. The last reviewed stamp is the very heartbeat of validity in CSC. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 12.2. This stamp allows future maintainers to determine whether the information is current, who last validated it, and what specific events require a re-evaluation. Trust depends entirely on knowing how recently constraints were verified. This encoding is handled within the recommended session closing prompts provided in the GitHub template. Temporal integrity. A stale contract is more dangerous than a codebase with no contract at all. Old constraints may reference removed systems, describe obsolete workflows, or preserve outdated assumptions that block necessary architectural evolution. This is why governance layers must include intentional review cycles. The review trigger. A repository must be able to distinguish between actively maintained rules and abandoned historical residue. With this distinction, the governance layer becomes just another layer of legacy cruft. Defense in depth. No single layer of protection is sufficient. We employ a three-pronged defense. Technical controls provide the immutable audit history. Branch protection, required reviews, commit signing, and CI enforcement ensure that the machine cannot be fooled. Human oversight provides the judgment. Architectural reviews, repository stewards, and code owners ensure that the law aligns with the business reality. Agentic safeguards provide the vigilance. Drift detection, contract validation, and the agent's own refusal to operate against unsigned or contradictory governance artifacts create a fail-safe boundary. CSC does not remove human authority. It attempts to preserve and externalize it more clearly. Governance requires stewardship. Without active stewardship, constraints decay, rationale disappears, workflows drift, provenance weakens, and operational memory fades. The enforcement layer exists to slow that decay and preserve trust in the governance structure itself. This decay is halted at each reconciliation, performed during the session closure provided in the GitHub template. We've introduced CSC enforcement, the role of provenance and the boundary between verification workers and judgment conductor. Enforcement, however, assumes the law is already correct. When the governance layer itself becomes inaccurate, the conductor must arbitrate a delta against an observed inconsistency and repair the contract. At any time, a software engineer, e.g. you, might realize a law in the contract requires revising.
Reconciliation. To reconcile, definition 1. To check a financial account against another for accuracy. Definition 2. To account for, explain. Blindly enforcing a stale contract is architectural malpractice. In the sterile world of software specification, we are taught that the blueprint is the truth and the implementation is the deviation. In production, the opposite is true. The code is the only honest artifact in the repository. It is the same unvarnished reality of what the system actually does. The governance layer, the contract.md and its satellites, is a map. Maps are useful, but they are not the terrain. When the terrain shifts and the map remains static, we enter a state of epistemic drift. The entropy of intent. Drift is a consequence of entropy. Repositories are living systems, meaning, in most cases, they are constantly changing. Architecture evolves, emergency patches become permanent behavior, and operational assumptions shift under the pressure of real-world load. Meanwhile, the governance artifacts often remain frozen in the moment of their creation. This creates a widening gap between the documented truth, what we say the system does, and the operational truth, what the system actually does. Anatomy of governance decay. Most drift manifests in 3 distinct failure modes. 1. Ghost invariance, outdated truth. The contract describes a constraint that has been surgically removed from the code but remains in the law. Example, a rule requiring a specific authentication handshake that was replaced by an API gateway 3 months ago. Surgical goal, to excise the ghost before the agent attempts to restore a dead behavior. 2. Implicit dependencies. Missing truth. The system depends on an invariant that is critical for survival but was never externalized. These are the tribal knowledge traps. Assumptions that every senior engineer just knows but are invisible to a stateless agent. Example, an undocumented requirement that service A must be fully initialized before service B can accept traffic. Surgical goal, to turn a hidden vulnerability into a falsifiable rule. 3. Hallucinated governance, incorrect truth. The contract asserts a rule that was never actually implemented, often because it was documented as intended behavior and then forgotten. Example: a policy claiming all data is encrypted at rest when, in reality, the volume mount was never configured for it. Surgical goal: to align the map with the actual terrain before the agent builds a feature on a lie. The reconciliation protocol. Contract reconciliation is the process of ensuring the operational truth, the code, continues to align with the documented truth, the contract. In contract-style comments, reconciliation of the repository is an act of auditing the alignment gap and updating the triumvirate markdown files. The protocol follows a rigorous sequence. 1. Detection. The worker, the agent doing the scoped work, identifies a contradiction. The worker is the one closest to the code, the one most likely to spot the gap between documented intent and operational reality. The worker does not fix the gap directly. The worker files a delta, a small structured proposal, to delta-log.we.md2. Arbitration. The conductor, the primary LLM in delegating mode, acts as adjudicator. That primary LLM determines which truth is authoritative, weighs the delta against the corresponding information in WHY. From Y and the delta, it will have the evidence it needs to evaluate whether the subagent worker's proposed change is sound. Finally, the conductor must approve or reject the proposal, and the process continues. The arbitration is recorded in the delta log row. The reasoning is recorded in YY if the change is approved. 3. Externalization. The reasoning for decisions about the codebase is recorded in Y, and the contract is updated to reflect the new operational reality. Current project law. If approved, the conductor performs the edit as the worker goes back to standby. Once committed to Git, that delta processing routine becomes the audit trail of why the change was made, especially useful for debugging. 4. Synchronization. The remaining members of the triumvirate are updated to ensure the operational loop remains valid. The conductor updates the affected triumvirate files. Crucial warning: never force the implementation to match a broken contract simply to achieve compliance or to close the alignment gap. What if the application behavior is tested, confirmed to be intentional and stable, but there remains a gap in alignment? Have the LLM audit the law of the contract first. In a multi-agent session, the prohibition of forced alignment is paramount. Should you find yourself in the habit of skipping the audit trail step, I recommend you delete the contract folder from your codebase and go back to sleep. The conductor. The primary LLM's authority and duty to reconcile is exclusive. Bypassing reconciliation is never an option. Detect the fracture. Will it cause a skarma? Drift usually surfaces as a contradiction. It is the moment the agent stops and says, the law says X, but the code does Y. Fractures, which lead to scarring, appear in several forms. Invariant violation. The implementation performs an action explicitly forbidden by the contract. Procedural collapse. The steps in Quick Start fail because the underlying infrastructure has shifted. Rationale conflict. The historical reasoning in Y contradicts a new, undocumented operational reality. Workers are uniquely suited for this detection because they operate as high-speed comparators. The conductor depends on the workers for the signal. The conductor is responsible for the decision. A worker who detects a fracture and does not file a delta has observed the system rot and remained silent. The delta log is how silence becomes proposal. Governing a living system. Your project, your codebase, is a living system, not a static archive. Your governance must evolve simultaneously with each evolution of the project itself. The triumvirate, contract, quick start, and Y might survive several actual code edits prior to itself actually requiring reconciliation, but the moment it does, it must be reconciled. Governance that cannot evolve is governance that will eventually be ignored. The goal in every contract reconciliation is simple. Build a high-frequency loop of detection, arbitration, and alignment. The stewardship of this loop is the human's responsibility. The agent can flag the drift, but only the human can exercise the judgment required to decide what the truth actually is. We have established the protocol for reconciling governance that has drifted from the code, with the conductor arbitrating deltas and the workers filing them. The hardest place to apply that protocol is where the assumptions are already buried in the code, and the governance layer does not yet exist, the legacy codebase.
The legacy codebase. A friend inherited a payment processing system as part of a work project. The original authors had long since moved on, leaving behind 50,000 lines of code and a single onboarding suggestion page titled, Things Not to Change. Half the code we're afraid to look at, he told me. The other half we're afraid to touch. This isn't a cautionary tale or a hypothetical scenario. This is what some people call the bus factor, when the dominant reality of production software exists in situations where loss of one engineer could mean inability to manage the code. We don't do our real work in pristine playgrounds. A real-world engineer might spend an entire day maintaining, adapting a legacy codebase that already handles live traffic, pays bills, and supports real human lives. Those humans have come to expect it to work, despite its fragility. Legacy code proves its utility in the wild. Behind the scenes, over years of deadline-driven shortcuts, shifting teams, and organic growth, a legacy system accumulates a patchwork of decisions. It becomes a delicate structure, held together by operational memory, unwritten rules, and the quiet prayer that nothing breaks. Now, introduce an autonomous AI agent into this environment. The agent has no concept of proper form, no motor memory, and no memory of the production scare from 2021 that made the team wary of the billing module. It opens the files and sees clean patterns to optimize, redundant code to prune, or old interfaces to modernize. But in a legacy system, that redundant code might be the only load-bearing pillar keeping a legacy reporting pipeline from collapsing at 3 a.m. The agent isn't malicious, it's just context blind. And a blind collaborator with direct code modification access isn't an assistant. It's a massive liability. If we are going to teach the world to use contract-style comments, we have to prove it here, in the live, inherited system. We need to show how to build an epistemic knowledge of the system layer that gives both human developers and stateless AI agents the motor memory they need to operate with form and precision without killing the patient on the operating table. The axiom of stability: governance first, refactoring later. The immediate instinct when inheriting a messy legacy codebase is to start fixing things. I understand the impulse. It's human nature to want to tidy up. You see a chaotic function, a deprecated library, or an unstructured database query, and you want to refactor it. Do not do this. It is a high-stakes gamble, and the odds are not in your favor. In a legacy codebase, load-bearing structures look identical to decorative ones. The ugly but essential functions are indistinguishable from the ugly and dangerous. Every change you make before you fully understand the system's identity is a wager. The CSC approach inverts this instinct completely. The objective is not to refactor, modernize, or try fixing everything at once. The objective is to stabilize our epistemology of the system, to ultimately populate the Y.MD contract with the knowledge we acquire through that process. Before you touch a single line of active code, you must build the cognitive scaffolding around the system. You need to externalize the memory that exists only in the minds of the senior developers, identify the invariants, map the fear zones, and document the scars. This is what we call the axiom of stability. Governance first, refactoring later. Imagine you are restoring a vintage Wonka widget. You don't immediately take a piece of sandpaper to the finish or swap out the hickey-do. First, you study the zig. You check the zag. You do a bit of research online to see what's trending on the topic, and you learn what it takes to fully understand the Wonka widget. I recommend you do that before you ever touch the Wonka to be true, for we never know where they come from. In fact, as of this published edition, official intelligence reported that Giorgio Tsoukalos said that in his opinion, you have to ask yourself, is it really about system stability? The analogy is this: the LLM should be so deliberately delicate yet thorough as it ingests your codebase. Think back to elementary school science class. It's your baseline. Testing anything else is irrelevant if you don't begin with a standard. The Wonka widget nonsense establishes the notion of baseline invariance. Understand the shape of the data and ask clarifying questions prior to committing any edits. CSC enforces that type of baseline for your LLM co-created projects. By establishing the triumvirate, you create a structured, machine-verifiable memory for the repository which spans across project sessions. When a project is managed with CSC, the engineer is operating with full contextual knowledge, the WHY, ensuring that any subsequent change is disciplined rather than speculative. The 4-step legacy onboarding sequence. The process of migrating CSC into a legacy system follows a strict, non-negotiable sequence. Each step builds on the previous, moving from the slow-changing, absolute law of the system to the fast-moving operational map. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 14.1, the 4-step onboarding sequence for live legacy systems, mapping rates of change to the triumvirate. Step 1. Contract.md, the dead zone. The first document you must establish is the contract.md. This is the absolute law of the system. In a legacy codebase, you are not writing an aspirational document about what you wish the system was. We might say, it's too late for that. What the legacy codebase needs from you now, more than anything, is for you to come up with a way to tell the LLM to ever so delicately discover and document what the system actually is right now. What does this messy old code do exactly? How many invariants must remain true for the system to survive? In keeping with our surgeon analogy from Chapter 1, maybe that's our anesthesiologist. Your legacy contract.md must capture 3 critical categories, the structural rules that already exist. Even if they've never been written down, we know they haven't been. For example, all transaction amounts must be stored as integers in cents, or the v1/charge AP. I must return a JSON response with a top-level status key. No-fly zones, the areas of the codebase the team has learned through painful experience to avoid modifying. These are the load-bearing walls of the system. The dead zone, undocumented but essential environmental dependencies, legacy cron jobs, or undependable libraries. If you touch these, the system will break in ways tests cannot detect. Here is a practical grounded example of a legacy contract.md. See the book for the visual example. Notice what this document does not contain. There are no suggestions for cleanups, no comments about how ugly the MD5 hashing is, and no feature proposals. It is a record of hard, unvarnished truth. It is the baseline from which all safety is derived. Step 2. Y.md, the lower extraction. Once you have documented what the invariants are, you must capture the reasoning behind them. This is Y.md, the teleology and history of the system. In a legacy codebase, this is where the skeletons and scars go. Every bizarre null check, redundant index, or strange ordering of execution in a legacy codebase has a story behind it. That weird check on line 247? It was added after a massive production outage in 2021, that redundant database query. It resolved a race condition that took 3 weeks to debug. Usually these stories live exclusively in the oral tradition of the team. They are passed down to new developers over coffee, or referenced in postmortems and then forgotten. CSC externalizes this tribal lore into the repository itself, turning human memory into an active, machine-readable asset. WHY.md, Legacy Payment Subsystem. Contract-.md, Invariant 2 exists, rounding logic. The rounding logic in app/billing/calculations.py handles 14 separate currency edge cases. In 2021, an attempt to refactor this module to use standard library decimal functions introduced a rounding drift that cost the company $47,000 in accounting errors over 6 days. The module was locked as a no-fly zone. It is ugly, but it is proven. The scar, the null check in middleware/off.py, line 247, added after incident number 142. A race condition between the database session pool and our auth token middleware would occasionally yield a null user context under high traffic. The null check acts as a load-bearing safety net to prevent cascading server crashes. Folklaw Saturday Certificate Warm-Up. The authentication server takes exactly 47 seconds to load its legacy certificate chain on restart. Any deployment to the auth service during business hours will cause a 47-second total outage. Deployments are restricted to Saturdays between 2 o'clock and 4 o'clock, Coordinated Universal Time. By recording these scars, you ensure that a stateless AI agent or a new human developer doesn't look at a piece of ugly code and assume it was just written poorly. They will see the scar, Read the history and respect the form. Step 3. Quick Start, the 3-minute map. With the law and history established, you need a practical map of the terrain. Quick Start answers a single question. How do I operate this system safely right now? The rule for a legacy Quick Start is strict and falsifiable, the 3-minute rule. A human developer or an AI agent must be able to read this file in under 3 minutes and understand the exact operational loop required to run, test, and verify changes without breaking the system. A legacy Quick Start contains 3 elements. The minimal loop, the absolute minimum commands required to start the environment and run the test suite. Proven checks, the explicit commands used to verify the system, is in a known good state. In your signals, the signs that indicate something has gone horribly wrong and that you must stop immediately. Quick Start, Legacy Payment Subsystem. See the book for this example demonstrated. If your Quick Start takes 20 minutes to read or relies on outdated instructions, the map has failed. Keep it simple, keep it current, and keep it focused on the fast path to verified safety. Step 4. Future.md, the standby queue. The final piece of the onboarding sequence is the future.md. This is your container for deferred work. Every legacy system has a long list of outstanding structural improvements. You want to upgrade to Python 3.12. You want to swap out the custom crypto library. You want to migrate from SQLite to Postgres. In a legacy codebase, this deferred list serves a vital safety function. It keeps AI agents in their lane. An AI agent has a native optimization drive. When it reads your codebase, it will observe old patterns, deprecated APIs, or suboptimal loops, and immediately try to fix them. If you don't explicitly tell the agent that these fixes are out of scope, it will assume the absence of a rule is an invitation to refactor. Future.md draws the boundary. It says that we know this code is old, we know this library is deprecated. We have chosen to defer this work for a specific reason. Do not attempt to fix this now. See the book for the demonstration. By placing these items in the standby queue, you satisfy the agent's optimization check while establishing a clear operational boundary. The future remains in the future, and the active sprint remains stable. The operationalization, how to extract legacy lore. The lore is the unwritten history of the code that everyone who's lived and worked it knows well. The LLM writes the triumvirate files according to the present tense law. Finding the information to put in them, especially when you've inherited a codebase where the original developers are long gone, is your challenge. Here are the practical techniques to extract lore and establish governance safely. The lore extraction interview. If you are fortunate enough to have access to long-tenured developers or operators who have maintained the legacy system, you must conduct a lore extraction interview. Do not ask them vague questions like, how does the system work? Instead, use targeted experiential questions designed to bypass their rationalizations and uncover the actual folklaws. The fear question. What is the single file or function in this codebase you are most afraid to touch, and what do you think will happen if we change it? This immediately uncovers your contract.md no-fly zones. This SCAR question. What was the most expensive or painful production outage we had in the last year, and what temporary patch did we introduce to fix it? This uncovers your y.md scars. The mystery question. Is there any part of this system that runs perfectly, but nobody on the current team actually understands how it works? This identifies your tombstone items. The folklore question. What are the unwritten rules of thumb that you follow when deploying or testing this specific system? This uncovers your quickstart.md danger signals. The danger scan. If you have no human maintainers to interview, the repository itself must become your informant. You can perform a danger scan using simple, read-only, terminal commands to identify the system's most fragile points. Locate the unchanged zones. Files that are actively executed in production but haven't been modified in years are high-probability no-fly zones. They are stable because they are load-bearing or because the team is terrified of them. Find the dark corners. Identify directories with zero test coverage. These are areas where an AI agent must not be allowed to perform refactoring, as there is no local safety net to catch silent regressions. Audit the Git blame context. Look for lines of critical code attributed to developers who left years ago on commits with empty or cryptic messages. These are context-free zones that require immediate tombstone documentation, the safe refactor loop, and the first commit. Once your contract.md, y.md, and quickstart.md are in place, the governance layer is installed. Now you must prove that the system works. The first commit under CSE governance in a legacy codebase should be deliberately small, trivial, and low risk. You are not trying to fix a major bug or introduce a new feature. You are verifying the process itself. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 14.2, the safe refactor loop. Safe governed changes under CSE, excellent candidates for a first governed commit, adding a hash contract, inline comment to a well-understood helper function, correcting a typo and a user-facing error message or logger string, adding a newly discovered environment variable invariant to contract.md. By executing the safe refactor loop on a trivial change, you confirm that the agent reads the law, respects the boundaries, runs the proven checks, and submits an easily auditable diff. Once the process is proven, you can safely scale to more significant modifications. The 50K LLC problem. Why agents require the triumvirate. Beyond the philosophical argument for clean governance, there is a hard, physical constraint. AI agents cannot hold 50,000 lines of legacy code in their active context.
Before and after. Intelligence without context is merely a faster way to break things. An agent with 1,000 billion parameters but zero architectural constraints is not an asset, it is a liability. To understand the utility of the CSC governance and its operational impact, we might look at the delta between two identical agents operating on the same codebase, with one variable changed, the presence of a formal governance layer. This is a study in operational blindness versus governed execution. The case study, the search feature regression. The environment is a standard Flask-based blog system. The request is simple: add full text search. Under the hood, the repository contains a critical, undocumented invariant. The getPosts function returns a specific dictionary structure. This structure is the load-bearing pillar for the front-end renderer, the export tooling, and the archive generation. In the codebase, this dependency is invisible. It is tribal knowledge, the kind of truth that resides in the heads of the original developers, but is absent from the logic, while the accurate data belongs in the triumvirate. Session A, operational blindness. In the first scenario, the repository is a naked codebase. The triumvirate is missing. The agent is operating in a vacuum of intent. The agent inspects the implementation and, exercising a flawed local optimization, decides to extend the function getPosts directly. It injects function, search query, and relevant score into the return dictionaries. On the surface, the task is a success. The search feature works. The agent reports a win. The silent collapse. Because the agent had no visibility into the system-wide invariants, it unknowingly triggered a cascade of regressions. Front-end fragmentation. The renderer, expecting a stable object structure, begins to behave inconsistently when encountering the new, unexpected keys. Export corruption. The /posts/export route now leaks search-specific metadata into clean archives, corrupting the output. The false all-clear. The agent attempts to verify its work. Lacking a map, it generates a Python unit test command for validation. The command completes without error. The agent's internal state is one of success. The system's reality is one of instability. This is the epistemic gap. The agent believes the system is healthy because its local verification passed, while the global system is degrading. Session B, the conductor's guardrail. The same task is repeated, but this time the repository is governed by the CSC triumvirate. Before a single line of code is touched, the agent performs a mandatory read of the governance layer. The contract explicitly defines the expected return structure of a getPosts function as a protected invariant. The WHY explains the historical scars, the production disaster that occurred the last time this structure was modified. This transforms the agent's mental model. It is no longer asking, how do I add search? It is asking, how do I add search without violating this law? In a multi-agent session, the worker who reads the governance layer is the worker assigned to the relevant silo underscore. The conductor has already populated delegation, and the worker is operating within its lock.
The triumvirate, the registry, and the delta log together are the load-bearing structure of the governed session. The governed outcome. The agent recognizes that modifying the getPosts function is a no-fly zone. Instead, it implements a separate, isolated function. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 15.1. New, isolated logic that preserves the original invariant. The feature becomes additive rather than destructive. The front-end and export tools remain untouched because the load-bearing pillar was never compromised. Procedural precision. Verification is no longer a guessing game. The quick start specifies the exact operational loop, PyTest. The agent executes the documented workflow, ensuring that the change is verified against the actual system requirements, not a generic test discovery command.
The operational contract, the only valid operation, is the one that is documented. We use the term a priori a couple of times in this book, and I want to break the fourth wall here, so it's not otherwise left for the glossary. A priori is hard to bargle Nartlezars with all its marbles in its mouth. Sure, it's Latin, it's in the Wikipedia, and it sounds awesome like Led Zeppelin. But what does it really mean? I'll tell you what it means. It means authors whose books are edited by an LLM shouldn't enable file write permissions in auto-approve mode. But for the darling lovable geniuses. Note, title for the next book, Anthropomorphicide in Real Time. Basically, a priori means a thing happens, regardless of any dependencies. That is to say, proposing it is sunny in London today is not a priori, whereas the proposition, either it is sunny or not in London today, can be known a priori. Governance does not stop at the boundary of the source code. If the rules that govern the code are externalized in contract.md, the rules that govern the runtime must be equally explicit. Operational invariants are not process details or best practices, but the very requirements of the system's survival. Deployment order, rollback timing, and environment isolation are just as critical as type safety or memory management are to operational health. If they are left to the whim of institutional memory, or what one might perceive of a context window, they will eventually drift. Runtime truth, the operational reality operational governance, decomposes into three primary domains of constraint. Mixing these leads to operational chaos and hero culture firefighting. 1. Deployment rigidity. Deploy contracts. The deployment process is a sequence of falsifiable states. A deployment contract defines the non-negotiable requirements for a change to move from staging to production. Pre-flight constraints. Mandatory integration tests or health checks that must pass. Prohibited operations. No-fly zones, e.g., no schema migrations during peak traffic. Verification gates. The exact telemetry markers that signal a successful deploy. The exit strategy, a deterministic rollback procedure that does not rely on the operator's memory. The goal is the total elimination of improvisation during high-risk changes. 2. Surgical protocols, runbook contracts. A runbook is the type of protocol our surgeon needed in Chapter 1. In the middle of a production outage, cognitive load is at its peak and judgment is impaired. A governance-infused runbook minimizes ambiguity. Let's check our patient's vitals and determine a prognosis. Atomic execution order. The exact sequence of commands, stripped of all conjecture. Expected state. What the output should look like at each step. The stop-loss. Clear conditions under which the operator must cease all action and escalate. A protocol is successful if it allows an operator to recover a system they have never seen before without ever guessing a command. 3. Environmental boundaries, infrastructure contracts. Infrastructure is the most common source of silent drift. When a quick change to a security group or a volume mount is made via the CLI and never recorded, the repository's map of reality is broken. Isolation invariance. The strict boundaries between production, staging, and dev. Persistence rules. Backup retention and replication requirements. Networking axioms. Assumptions about load balancing behavior or VPC peering. Without explicit infrastructure governance, the system becomes a black box, where the only way to understand the environment is to poke it and see what breaks. The silent decay of operations. Unlike code failures, which often manifest as loud crashes, Operational drift is a slow, quiet accumulation of risk. It begins with a temporary emergency fix that becomes permanent behavior. Then, a deployment script is tweaked to bypass a flaky test. Then, a senior engineer leaves the company, taking the knowledge of why the rollback sequence is so specific with them. Eventually, the system reaches a state of operational fragility. Deploys become inconsistent and feared. Onboarding new engineers takes months because the way we do things is undocumented. Outages that should take minutes to resolve take hours because the a priori instructions are stale. By treating operations as a formal system of law and rationale, we transform tribal knowledge into a machine-readable asset. The inference trap in production. An unconstrained agent allowed to edit files in production infrastructure is a catastrophic risk because, as we know it does in code, the agent will attempt to fill a void of information with probabilistic inference. This is what's referenced in our industry when you hear others mention an hallucination of generative AI. Practice makes perfect, so we'll walk through the processing workflow once more with a different set of examples and slightly different concepts, and you've nearly graduated from Agent Governor School. Look at you. If the agent is told to fix the deploy but lacks an operational contract, it may guess a rollback command based on common patterns, e.g. get checkout versus a complex blue-green switch. Infer that a priori deployment freeze doesn't apply to a small fix. Invent a verification step that looks successful but ignores a critical system failure. Operational governance provides the agent with a deterministic rail. It replaces inference with verification, ensuring the agent follows the established protocol rather than gambling with the system's stability. The conductor's veto. Regardless of how advanced the tooling becomes, the definition of risk is the human's function. The conductor's authority over the operational layer is exclusive. In a multi-agent session, no worker may modify the operational triumvirate, the deployment contracts, the runbook protocols, the infrastructure boundaries. If a worker observes that an operational invariant is wrong, the worker files a delta. The conductor arbitrates. In a solo session, the human holds both roles, and the discipline of writing the delta before editing the contract is the same. The conductor determines the threshold for acceptable risk, the strictness of approval boundaries, the ultimate decision to trigger a rollback. Operational governance is about preserving human judgment, not yet replacing it with complete agent autonomy. By externalizing the routine practice and the rigid constraints as law, the human is free to focus new ideas, enhancements to features known to be good ideas, the detailed analysis and qualitative judgment required to debug and overcome obstacles during a true crisis, and successfully move on with continued production once any crisis in the past. We have extended the concept of the contract from the source code to the runtime environment. An operational contract, however, is only as reliable as the tooling that enforces it. The systems that validate the triumvirate and automate governance-aware workflows are what make the invariant survive contact with production.
Agentic tooling. Autocomplete is a productivity tool. Governance is a survival tool. Generating 1,000 lines of code in a second is a feat of engineering, until you realize you've just accelerated the erosion of your architecture. The current AI tooling landscape is obsessed with the wrong metric. The industry is optimizing for throughput, faster autocomplete, larger context windows, instant refactoring, and aggressive generation. But long-term system failure is rarely caused by a developer typing too slowly. It is caused by drift. It is caused by broken assumptions, undocumented invariants, and the silent, steady erosion of architectural intent. Generating code faster does not solve these problems. In the absence of governance, it merely accelerates the disaster. Game velocity. Most AI coding tools optimize for the developer experience, DX, which is usually code for convenience. They prioritize local correctness. Does this snippet compile? Does it pass the immediate unit test? This creates a dangerous illusion of progress. An agent can produce code that is structurally clean and superficially correct, while simultaneously violating deep-seated repository assumptions. Hard architectural boundaries. Critical operational workflows. Fragile downstream dependencies. The problem is a lack of constraint, not a lack of intelligence. The mechanics of erosion. Repositories do not collapse in a single event. They fail through 1,000 small local optimizations. A quick cleanup that removes a seemingly redundant check. An undocumented refactor that subtly shifts an API shape. An agent inferring a global rule from a partial context window. A workflow shortcut taken during a midnight deployment. AI tooling can unintentionally catalyze this decay because it optimizes locally while inferring globally. Without explicit, externalized constraints, the agent fills the void of missing intent with probabilistic guesswork. Beyond the editor, synthetic governance. Instead of enhancing the drill, we need to enhance the system which learns how to discover oil. We need a stronger governance system, not a smarter editor. We need tools that treat the triumvirate as a first-class citizen. Governance audits. Contract linters. A governance-aware linter doesn't care about your indentation, it cares about your invariance. It validates the structural integrity of the law. Scope leakage, detecting when contract.md accidentally contains speculative plans instead of active constraints. Rationale pollution, identifying when y.md is being used as a manual for operational instructions. Constraint contradictions, flagging when two governance files make mutually exclusive claims about the system. Intent shift analysis, epistemic diffs. Traditional diffs are textual. They tell you what characters changed. An intent shift analysis asks, what assumption changed? A three-line textual change can represent a massive architectural pivot. A governance-aware system surfaces this explicitly. This change modifies the return shape of the function, getPosts, which is a protected invariant in contract.md. Boundary verification, invariant validation. Instead of merely checking if the code runs, tooling should validate governance correctness before a change is ever committed. It treats the contract as a test suite for the architecture itself, ensuring that no modification violates a no-fly zone or an established boundary. Throughput versus integrity. There is a fundamental tension between the goals of raw generation and the goals of governance. Visible diagram missing from audiobook. Please reference Master of the Lake, Figure 17.1. Those who prioritize velocity over integrity are simply building a faster way to reach a state of unmanageable technical debt. The new center of gravity. Historically, the IDE was the center of the software universe. But as the cost of generation drops towards zero, the center of gravity is shifting. The agent is becoming the executor, the high-speed engine of change. But the engine is useless without a steering mechanism and a set of brakes. That role is now filled by the governance layer. In this model, the triumvirate is the constraint system. The conductor is the role that holds the law, in solo practice, the human at the keyboard. The workers are the roles that execute within the boundaries, each in its own silo, each filing deltas when the boundaries need to change. The registry and the delta log, delegation.md and deltalog.md, govern, respectively, who owns what right now and how the law evolves. The registry, the delta log, and the triumvirate together are the load-bearing structure of the governed system. Governance before generation. The CSC framework argues for a reversal of the industry's current priority order. The wrong way: generate, then implement, then maybe document, then fix drift. The governed way: define constraints, establish the no-fly zones. Preserve rationale, document the operational scars. Define procedure, map the operational loop. Generate safely, execute within the established boundaries. If you generate first and reconstruct intent later, you have already lost. By the time drift is visible in the code, the original architectural assumptions have often been erased. The final challenge. The long-term challenge of the AI epoch is the search, the correct answer to the real question. How does a complex software system remain coherent while multiple agents continuously modify it at 1,000 times the speed of a human? CSC attempts to solve this problem, but CSC is just a tiny speck of a drop in a dream you had last week, which you already forgot about by the time you tried to remember it the next day. I don't think you're going to remember it now. Who's to say? The mind is a peculiar and delicate companion to consciousness, it seems. We are presented a governance problem, not an issue to be addressed by steering the agent in code generation. Tooling for the multi-agent model is not yet mature. For example, a contract linter engineered to validate the triumvirate integrity is in prototype. The intent shift analysis that surfaces delta candidates has been sketched. The invariant validation that tests the law against the code is in early use. What is missing is tooling that understands delegation.md and deltalog.md as first-class artifacts, tools that surface collisions before they happen and surface stale deltas before they rot. That is the next layer of the framework.
Intent and variance, the social contract. The most dangerous asset in a repository is an agent that believes it understands your intent without ingesting the project spec. For the vast majority of computing history, the relationship between a human and a machine was deterministic. We wrote instructions. The machine executed them literally. The machine did not interpret our desires. It simply performed the sequence of operations we provided, even when those operations were catastrophically wrong. We have entered the age of the probabilistic interface. LLMs do not execute instructions in the traditional sense. They interpolate, generalize, and pattern match. They fill the gaps of missing context with a high-confidence guess. When we move from writing code to steering agents, we are no longer managing a tool. We are managing a system of interpretation. Variations on intent. In traditional engineering, the primary challenge was implementation. How do we make this work? In agent-assisted systems, the primary challenge is governance. How do we ensure the agent doesn't destroy the system while trying to make it work? Because agents are brilliant amnesiacs, stateless and prone to inference, they naturally optimize for local success. They want to provide a response that looks correct in the immediate context. They are not naturally concerned with long-term system integrity, architectural coherence, or the operational scars of a decade-old production disaster. Without explicit governance, every agentic interaction is a gamble. You are betting that the agent's probabilistic inference of your intent matches the actual architectural requirements of the system. Authorship to governance. The role of the human in the software lifecycle is undergoing a fundamental shift. Software development used to be about coding, or authoring. Now it's about learning to govern a genius with a short attention span who may also be the steward of your codebase. When we reference the steward in this context, we're referring to the primary LLM, whether it has delegated subagents or not. The primary LLM is always the steward. Authorship focuses on the line-level production of code. Stewardship is a practice committed to ethics of the embodiment of a responsibility for planning and management of resources. Think of a proxy or a liaison. The primary LLM is steward of code on the human's behalf because the steward owns the role, likely resulting from a history of good performance. In a governed system, the human's primary output is no longer the implementation itself, but the formalization of intent. The steward spends their time defining falsifiable invariants, externalizing architectural no-fly zones, curating the repository's memory of operational failures, arbitrating between operational truth and documented truth. The primary LLM's role as steward is further stratified when it has delegated sub-agent workers. The conductor is just the primary LLM while orchestrating or conducting its team of workers. In both cases, the primary LLM's output is the formalization of intent, but the steward's workflow depends on the number of workers, which may be 0. A solo steward can edit the triumvirate directly. A multi-agent steward must wait until it has processed its adjudication upon the worker's proof of work. Authority to edit the triumvirate is exclusively granted to the primary LLM at all times. No other role-based worker may edit the triumvirate. The conductor can't edit the triumvirate until processing adjudication. It must accept deltas from workers and arbitrate. This does not reduce the importance of human expertise. It elevates it. Precision, clarity, and governance discipline are now more valuable than raw coding velocity. A poorly defined contract doesn't just lead to a bug. It leads to a system that actively works against its own architectural intent. Guardrails interpreted the repository has evolved. It is no longer just a storage container for source code. It is a shared cognitive space. It is a memory structure that allows a human with a long-term plan and an agent with a finite context window to maintain a synchronized model of the system. The triumvirate, the law, the teleology, and the map is the mechanism that prevents this synchronization from collapsing into a mess of contradictory assumptions. Governance artifacts provide the guardrails of interpretation, mitigate the risk of guessing. The fallacy of unconstrained autonomy. There is a pervasive and dangerous myth in the industry, the idea that if we just make the models smarter, they will eventually figure out the architectural intent without needing explicit constraints. That is a fantasy. Autonomy without constraints is simply delayed instability, at this point in the timeline of artificial intelligence memoirs. The more autonomous an agent becomes, the more crucial it is to define thoughtful, meaningful constraints. A governance-infused agent doesn't want freedom, it wants a high-density, unambiguous map of authority. At scale, the move fast and break things mentality becomes a liability. When agents can modify 1,000 files in a second, breaking things happens at a speed that can outpace a human's ability to recover. Governance is the only mechanism that allows for acceleration without systemic collapse. Governance as the new literacy. As agent-assisted development becomes the baseline, the ability to define and maintain governance layers will become a foundational engineering skill. The professional engineer of the next decade will not be judged by their ability to produce raw code volume. The agents have that covered. They will be judged by their ability to structure a maintainable system of constraints, preserve the a priori rationale for architectural decisions, communicate intent with surgical precision, design a governance layer that prevents the agent from gambling with the system's stability. Clarity of intent is the new high-status skill. The larger shift. The fundamental challenge is no longer a technical one. Can AI write software? We know the answer is yes. The real challenge is an organizational and epistemic one. Can we maintain a coherent, stable system while multiple intelligent actors continuously modify it at machine speed? That is not a problem that can be solved with a larger context window or a faster model, but it is a governance problem. We have explored the shifting relationship between humans, agents, and intent. What remains is to turn this framework back onto itself, to apply the principles of governance to the book, the specification, and the evolution of the CSC framework itself, the meta-contract.
A compiler is finally real when it can compile itself. A philosophy becomes real when it can govern its own evolution. The genesis of the CSC methodology was not an academic exercise in governance. It was a desperate response to the friction in collaboration with AI. The industry was enamored with the tooling gold rush, racing to implement faster autocomplete in larger context windows. We grapple with the visceral reality of drift. Whether I was building a wine pairing concierge or an interactive guitar fretboard trainer, I encountered the same recurring failure. The agent would brilliantly implement a feature while simultaneously eroding the architectural intent of the project. I had used the full spectrum of AI-powered IDEs, from the early days of Copilot to Llama and local models. I found the experience fundamentally lacking and flawed from the ground up by developers blinded in fascination. The magic of a billion parameters must not be undermined by the sterile amnesia of the session. I don't want to learn a new tool to learn to use AI. I want to learn to use AI, period. CSC makes it possible to use AI efficiently without the need to learn new tools. Beyond its own files, CSC doesn't ask you to learn to author a skills or agents file, or maintain some kind of .cloud.memory.what file mysteriously appearing after using whatever proprietary IDE environment I might have had the pleasure of trying that day. Find your visionary perspective on AI. What was mine? Basically, you can't write the next Node.js if you're too busy learning Node.js. Stop gambling with the generative output. Invest your time. Find your return. The praxis of the framework. In compiler theory, self-hosting, the point where a compiler can compile its own source code, is the ultimate marker of maturity. Is CSC self-hosting itself? I don't think so, but it is in praxis. Let praxis be candidate for word of the day. A praxis is the practical application of a theory, the process of using a theory or something learned in a practical way. CSC is in praxis. That is, it is different today than it was yesterday, and it will continue to change. CSC is simply a specification about logical ideas, and it's as much yours as it is mine. Better yet, make it more yours than it is mine, and don't look back. This manuscript has achieved a version of that milestone. It's a governance framework that evolves and maintains itself through its own governance process. While not perfect, it serves as an operational proof of concept. The methodology is not merely theoretical. It is the very thing that allowed this book to reach a state of coherence. The maturity milestone, a compiler that compiles itself, has, with the addition of the conductor/worker hierarchy, become a network that governs itself. The triumvirate, the registry, and the delta log are the artifacts the conductor uses to govern the workers. They're simply the same contract files you know by now, with book_prepended. Those are the artifacts the metaconductor uses to govern the manuscript. We just made a subfolder and prepended book to the regular contract file names. You could do it with any project. For the book manuscript, the CSC governance is applied at 2 levels. I already had a simple, private, personal coding notes and odds and ends kind blog on my development server, which is kind of like a super slim version of Grav, a flat file content management system website framework, getgrav.org. Mine is a Python Flask app, which reads plain markdown files from a directory and renders it as stylized HTML in the browser. You've seen that setup in a ton of websites, but you probably don't realize it unless you're in the back end, authoring the content as Markdown. I deleted all of my plain Markdown files from my Python Flask Markdown Reader private blog thing and replaced them with plain text version of the manuscript. Each chapter is its own Markdown file, and a naming convention is Pandoc friendly for creating chapter titles when rendering a PDF, for example. My Flask blog shows me the chapter names, and I can edit them as needed. I copy-pasted that plain Markdown into Sublime Text and removed all of the special Markdown formatting characters, and copied that cleaned, completely plain text and pasted it into my story creator, tVOX Online, www.tvox.online. tVOX Online renders audio from the text input, otherwise known as text-to-speech, which is an AI enhancement recently available to the public at the time of writing. I use low-cost or F-free provider called Together AI to generate the slides as the TTS is rendering in the background. tVOX was the natural evolution from the Flask blog for me because I wanted to be able to review the manuscript as an audiobook while I was doing other things. That's multitasking. After placing the Markdown files for the book into the Flask blog, I then initialized the CSC contract in the same folder where the manuscript Markdown files live, so it became the book_contract.md so I can manage the state of my book. So this idea of CSC being a compiler that compiled itself is misleading in the sense that I discovered it by accident. The CSC structure is preserved by the same structure it prescribes, so the LLM only needed to update the CSC boilerplate from the GitHub repo I cloned into the manuscript draft folder. It was that moment when the manuscript setup I just described came together so naturally and brilliantly, I realized I had to share the CSC framework with you. As this manuscript grew, it became clear that the act of writing long-form technical material with an LLM suffers from the same pathology as maintaining a codebase. Consider the following: context drift, terminology mutation, style instability. They are the literary equivalents of the technical debt discussed throughout Master of the Lake. I engaged the LLM to help me when I first started writing the book, but I quickly realized that a book written with AI eventually becomes a fragmented collection of helpful suggestions, lacking a coherent voice or a stable architectural spine. It occurred to me that I had just developed the CSC framework, obviously, as I was then engaged in writing a book about it. To solve this, I treated the manuscript not just as a collection of thoughts about what I wanted to tell you here, but as a repository. I implemented a literary triumvirate. For the book, the contract.md is the voice and boundary layer. This was the law of the manuscript. It defined the non-negotiable elements of my voice. I wanted to ensure any LLM passing over the manuscript for grammar, continuity, etc. would do so under a mutation of the regular CSC governance rules. Invariants like, no bullshit, no corporate filler, no exaggerated futurist claims, no vague philosophical abstractions. I got your back. Preconditions. Every example must remain grounded in production realities and operational scars. The cadence, the formal rogue tension between academic rigor and conversational grit. And so on like that for the book's own triumvirate. The narrative rationale goes in the book contract's wayshay.md. This captured the surgical history of the book. It documented failed drafts, rejected structural experiments, and the reasoning behind specific narrative pivots. It ensured that the manuscript was shaped not by accident, but by design. Quick Start became the authorial loop. This gave the creative process a specification-based procedure, defining such considerations as a cold start review process, a terminology audit, and the exact workflow for moving a chapter from a revised draft to publisher decisions, offloading the epistemic burden. The most immediate result of this approach was a profound reduction in cognitive overhead. Collaboration with an agent is traditionally an exhausting exercise in, quote, context babysitting. You spend half your time re-explaining boundaries, correcting drift, and translating intent. By externalizing the constraints, I shifted the memory burden from the human to the repository. The interaction changed from a struggle of repetition to a process of refinement. The agent no longer needed to figure out the voice. The voice was a documented invariant of the system. After a great deal of commitment, and my natural tendency as a teacher to want to share with you my triumph in CSC, and a ton of work, from authoring blog posts and creating the GitHub repo to creating tVOX Online, which I use to produce the audiobook version, it seems this book, which could be no better proof of concept for how to use CSC for project management and boost productivity while mitigating context drift. Final note: the scaffold for imagination. There is a common misconception that governance is about adding ceremony or red tape. It is actually the opposite. Governance is the process of removing the invisible assumptions that stifle creativity. When the boundaries are explicit and the project truth is externalized, you are free to iterate at high velocity. See what you can do with it. CSC does not impose additional labor on the human. The agent handles the mechanical governance infusion in seconds. Instead, CSC provides the structural integrity required to survive the acceleration of the agentic era. Use this framework as the scaffold for your systems, your projects, and your imagination, your vision of our future. Give an LLM some code. It will refactor it for a day. Teach an LLM some code, and you are master of the lake. In this agentic epic guided by madness and probabilistic inference, the only way to maintain a stable identity is to write the law, uphold the law, and continuously reconcile for amendments. Now, go forth and govern. Find the template at github.com/ajaxstardust/contract style comments and leave a star. Why not? Thank you for reading.